All right, good afternoon. Let's take a quick look at some rules of dimensioning and especially how it relates to our finger engine drawings. So all of the rules of dimensioning are controlled by the ASME Y14.5 standard. The most up-to-date one is the 2009 standard, but this is a standard that everyone has to follow when they're creating drawings, and it is legally binding. So make sure you're paying attention to your drawings because they literally are a contract. So a detailed drawing is going to be the way we document any given part. We use a top, a front, and a right side view. Those are orthographic projections, and the dimensions necessary to manufacture the part. There's some rules on how we pick those dimensions that we're going to be covering. You'll also see an optional 3D view in the upper right corner and a fair amount of information provided in a title block on the bottom right corner. So here's a picture of the post drawing. You'll see that in the upper right corner is that 3D isometric view. When we pick that isometric view, you want to be able to see as many features as possible. So in this one, you'll see the holes at the bottom right corner. There's a top view and a front view and a right side view, and these are called orthographic projections because they are perpendicular to each other. The title block has a name and a date, has a title of the part, and it has what size the paper is. That B size is that represents an 11 by 17 piece of paper. Okay, when we're picking dimensions, we want to have the total size and location of each feature documented. We don't want to have any assumptions, and we have to have all of the necessary dimensions for the end project. Dimension should be selected to suit the function of the relationship, and we don't want to tell how to manufacture it. We don't want to tell the machinist how to do their job. So here's an example of the connecting bar, and I've mentioned this several times throughout the course, but let's repeat it. The connecting bar it connects between the lever and the crank block. The only function of this bar, the only thing that matters, is those holes and the distance between them. If the bar were wider or a little bit longer or rounded, it wouldn't really matter. But the most important thing about this object is the holes, their size, and their center to center location. So in the machine shop drawings, all of this information is given as a reference relative to the left-hand side, and that works well for learning how to machine. But when it comes to providing a detailed drawing of the connecting bar, it's important to provide the center to center distance. That is what's important. The 2.926, that is more important than saying where the end hole is relative to the far left-hand side. So we want to focus on the function of the part, and in most cases, the hole location is the most important function of the object. So these holes are located center to center, distance to the left. This connecting center line here allows us to apply the 0.25 dimension once, so that applies to both. And that 0.25 is relative to the overall height. The 2x shows that we have the same hole diameter listed here twice, but it goes all the way through. Again, nothing's assumed. We're explicitly stating all of the information. When we dimension a part, we really want to focus on clarity and design intent. So if you're not sure, you want to come back to clarity. How can I make this clearer? We're going to focus on some lines, some spacing, and how we select dimensions to help us along this path. When we're looking at a drawing, for example, that post drawing, we have visible lines, which are the geometry that's all the way around the outside with the circle and the edge. We have hidden lines, such as this hole up here. When I look at the top, as I look at the top of the post, I don't see it. So those hidden lines are the skinny with small dashes. We have center lines, and these center lines are the long, short, long lines that show the center of circles or holes. We also have center marks, and the center marks are the little plus sign at the center of any circles. The dimension lines are the lines with the arrowheads that help us show where the dimensions are located. Extension lines are these skinny lines coming off of the object that the dimension line falls between. And then leader lines, such as these circles with their pointing leader lines. When we're just checking out those extension lines, you want to make sure there's a little bit of a gap between the feature that you're dimensioning and the extension line. Okay? You don't want to have the gap off of the whole part, but just off of the feature. Looks like my diameter symbol didn't work out very well here. That's all right. We'll just throw that on there. So the diameter symbol is a circle with a dash through it, and the depth symbol is a line with an arrow that comes down. I believe these dimensions or images work fine in the PDF that's online. Your isometric view in the upper right corner is not going to have any hidden lines, or it's either no hidden line style or you can have it as shaded. All right. When we're using any writing on a drawing, you're going to use uppercase letters unless lowercase is required, such as inches or millimeters. We typically don't have serifs when we're dealing with technical fonts. Make sure you have a minimum lettering height of 1/8 of an inch or 3 millimeters. There are some symbols available for you to use in Onshape. We do want to use symbols in place of text as much as possible. Occasionally, there's a few in the character map that I like to use frequently, the diameter symbol. Okay, so the character map you can find in Windows. Here's an example of that diameter symbol. And if you find a symbol that you use often, you might find a keystroke that makes it a shortcut. So holding down the Alt key and using the number pad 0216 will give you that diameter symbol. You'll find references for more symbols available in many places, including the Machinery Handbook or here on my courses. We want to use clean placement of leaders and arrowheads to make this as clean as possible. The view on the left here is definitely not a great view. The view on the right is much cleaner. So arrows should not overlap themselves or text. We want to flip those to the other side if we can to make it nice and clean. Leader should point through the center of the arc, so this leader here should go right into the center of that arc. And you really want it to be kind of have a nice angle to it. So between 30 and 60 degrees. You want to avoid having those horizontal or vertical leaders associated with holes. Dimensions can be horizontal or vertical or angled. We have angles as well. We don't typically show 90-degree corners or 360 degrees or 180 degrees. Anything that's really obvious, we're going to leave off. Notes, we can have callouts that have threads and depths for holes. We can have radii or diameters. Usually this dimension tool is that the D dimension tool is going to try its best to pick what it thinks you want. But if you want to force it, there are other options that you can add in. You can add in your own diameter dimension, or you can tell it that you want a point to line dimension. So you can kind of force it to do what you want. Or you can do the dimension tool and just see if it gets it right on its own. When we're placing our dimensions, we don't want to dimension hidden lines. So to avoid that, you can try moving the dimension to another view. You can add a section view, which we'll cover later. Or sometimes you can pull that piece of information into a note. You want to make sure the dimension values are clear. You don't want to have anything that crosses the dimension text. Move your dimensions so that they're outside the object. Try to avoid having anything cross dimension lines if you can. And try to make things nice and uniformly spaced out. So this is not a great view. We want to pull these dimensions off. We don't want a dimension to hidden lines. That's a dimension to a hidden line. So there's definitely ways that we can make this a lot better. Pull these dimensions off. Move this one out further to avoid the dimension line crossing through the extension line. Right, and you can see that with the depth information here, so this is hidden, but we'd want the whole depth added to the end view, the right side view. All right, so here's an example of a setup for the crank block, and you would want to make sure that you had size and shape for each feature.